Let's talk about every developer's worst nightmare. You build something amazing, you launch it, and you watch it collapse under the weight of its own success. Today, we're diving into Apache JMeter, the tool designed to make sure that when success comes knocking, your application is ready to answer the door.
It's such a simple question, isn't it? But the answer has huge implications. You've poured countless hours into your app, but what actually happens on launch day when everyone you hoped for, and more, logs in at the exact same time? That viral success you were dreaming of can turn into your biggest liability if you're not prepared for the flood.
Let's just paint a quick picture here. It's Black Friday. Your marketing was an absolute home run. Now, 10,000 people are all trying to check out on your site at once. Is it going to hold up, or is it going to grind to a halt and become a case study in lost revenue and angry customers? This is exactly the kind of fire we can learn to fight before it ever even starts.
So, how do you get ready for that digital flood? Well, you don't just cross your fingers and hope for the best. You simulate it, you test for it, and you find and fix the cracks before they turn into catastrophic failures. And that is where our star player comes in. Meet Apache JMeter. I want you to think of it as a movie director for an army of virtual users. It lets you simulate thousands or even tens of thousands of users just hammering your application, your website, your API, whatever it is, all at the same time. And the goal here isn't just to see if it bends, it's to find the exact point where it breaks so you can fix it long before a real customer ever has a bad experience. So, why JMeter over anything else? Well, a couple of things really jump out. First, it's open source, which means it's totally free. No massive licensing costs. Second, it's cross-platform, so it doesn't matter if you're on Windows, Mac, or Linux, it just works. But the real magic is that it's both incredibly versatile. I mean, it can test everything from websites to databases, and it has a GUI, which means you can build really complex stress tests without being a scripting genius. It really just makes performance testing accessible to everyone. Okay, so it's powerful, but that usually means it's hard to use, right? Well, let's walk through building a basic test together. You're going to see that the core concepts are actually surprisingly simple. Honestly, building a basic test really comes down to these 4 steps. First, the thread group. Think of this as your crowd of virtual users. How many people are you inviting to this party? 10? 1,000? Next, the HTTP sampler. This is the script you give each user. Go to the homepage or add this item to your cart. Then you add a listener. This is your control room, your dashboard, where you see all the data pouring in. And finally, you just hit run and, well, you unleash the virtual horde. And this is the moment of truth, the aggregate report. You're looking for a few key things here. The average response time, lower is definitely better. Throughput, how many requests per second, you want that to be higher. But then look at the error percent column. The login and home pages, they're perfect, 0% errors. But that search API, it's failing 2% of the time. Now, that might not sound like a lot, but on a busy day, that's thousands of failed searches and frustrated users. Just like that, we've gone from a vague feeling of the site is slow to a very specific diagnosis. Something is wrong with the search. A basic test is a great start, but let's be honest, real users are not robots. They don't just click things as fast as possible. They pause, they think, they get distracted. To get results that actually mean something, our simulation needs to mimic this messy human behavior. So let's see how we add that touch of realism. This is where timers come in, and they are so important. Think about how you browse a website. You click a link, you read the page for a few seconds, and then you click something else. That little pause is what we call think time. Without it, you're pretty much just launching a denial of service attack on your own server, which isn't a very realistic test. Timers add those crucial, natural delays, making your simulation act much more like an actual person. It's not enough to know if the server just responded. You need to know if it gave the right response. That is what assertions are for. Just like the slide says, you can tell JMeter, hey, after someone logs in, I need you to check the page for the words welcome back. If those words aren't there, it's a failure, even if the server technically sent back a success code. This is how you test for correctness when things are under extreme pressure, not just raw speed. This slide clears up 2 really powerful concepts that can sometimes be confusing. On the left, you have parameterization. That's all about feeding unique data into your test. So imagine a big file with 100 different usernames and passwords. This makes sure each of your virtual users is doing something unique. On the right, you've got correlation.
This is about catching data that the server sends back to you, like a temporary session ID, and then using that data in your very next request. You absolutely need both to simulate a realistic user journey.
All right, so we've run a realistic test and we've found some problems. Now what? I mean, this is the whole point of the exercise, right? To identify the bottlenecks so we can actually go and fix them.
When you find a performance issue, it almost always traces back to one of these 4 usual suspects. Is the CPU on your server just maxed out at 100%? Is the server running out of memory? Are your database queries taking forever to run? Or is the network itself the problem? JMeter is great because it shows you the symptoms from the outside, and when you combine that with some basic server monitoring, you can pinpoint the exact cause.
Now for a super important pro tip, the GUI is fantastic for building and debugging your tests. But when it's time for the actual high-load run, you have to use the command line. The GUI itself actually uses up a lot of memory and processing power, so running in non-GUI mode ensures that your test results are as accurate as possible. Plus, as a nice bonus, this is how you generate those incredibly detailed HTML reports that are perfect for a deep analysis later. Okay, to wrap things up, let's just boil all of this down into a few key best practices. If you follow these simple rules, your performance testing is going to be way more effective and reliable.
So let's put it all together. These are really the golden rules. First, always, and I mean always, run your big tests in non-GUI mode. Second, limit your listeners during the test run. They eat up memory. Third, you've got to use timers to simulate real human pauses. Fourth, use a gradual ramp-up period. Don't just slam your server with 1,000 users in 1 second. And finally, maybe the most important rule of all, always establish a baseline. Test with one user first, so you actually know what good looks like before you start ramping up the pressure.
And that really leaves us with one last thought. Every single application has a limit, a specific number of users where performance starts to tank or things just break entirely. JMeter is the tool that helps you find that number, not by accident during a disastrous product launch, but by design, in a safe, controlled test. So the question is, do you know your number?